It's so cool seeing so many people here today. I guess actually you've been seen this room already many times on the news if you see the background. So actually it's quite serious stuff which is happening inside this room. So, but I think it's so cool being here talking about something else, like for example Kafka, which we were talking about today. So just a minute and I am ready. Okay. So the title of our presentation is Catching Criminals with help of Apache Kafka. It's actually some kind of journey where we are telling about our experience with Kafka. And we're going to look at some our existing solution on some area, which I'm going to talk more about, and see how we have addressed the limitations and challenges and so on, and looked how actually Kafka could help us solving our problems. There are many people, I think, that talks about event-driven architecture, especially in my company. But I'm very proud that we're not just talking, we're doing. Our system is in production right now. So it's not just about our plans. It's, yeah. So this is our agenda of today. First, I will say a little bit about our mission, my mission as a developer here in Politiets IT-enhet. I will continue introducing my team, which is Team Grensekontroll or Border Crossing, and our domain. The reason why I will talk a little bit about this is because it's actually one of our applications where we have, which is replaced by a solution based on event-driven architecture and Kafka. So the actually area we are solving, it's about scanning of documents, where we will look about challenges and limitation, and then we will continue to see actually how we solve this by using event-driven architecture and Kafka. I will give you a little demo. We're not going to look at the code, but we're going to have a demo of Jaeger, which is a tool of how to track actually our events. We then see how we have addressed known limitations, and finally we're going to look at data as a product, which is a very, very interesting area, especially for our business, which I represent. I'm not going to talk so much about myself, but my name is Rune Høivik. Actually, my plan was to become a police officer, but instead I ended up in Trondheim becoming an engineer. I think that was okay for me. I would not become a good police officer. But But after working many years as a consultant, I realized that our domain is very important for me. So I guess that's the reason why I ended up here in the police, because I actually find what the police is doing is so important and so interesting. So that's why I'm here today, and so I think we just, very short, as the police is actually dealing with some of the most important things in our life, which is safety. It's about protecting us. Without safety, you actually have nothing. That's my opinion. So I feel really pleased that I, as an engineer and a developer, actually can use technology to help our police to getting a better place for all of us. So this is the picture of actually what my team is dealing with. I'm working as a developer of Team Grensekontroll or Team Border Control. So my job is to ensure that our officers are able to check and verify that travelers have valid admission to the Kingdom of Norway. This is mainly regulated by something called the Schengen Agreement, which Norway is a part of. This can happen at many places, as you can see here, at sea. At the harbor is the boat from Denmark to Oslo. It could happen at airports, mainly at Gardermoen, but also at other big airports in Norway, Flesland and Trondheim. And of course, at our national borders, which you see the picture here, it's from our border to Russia. So, yeah, we're living in a time where the political landscape is quite chaotic. So the world is changing, and our safety, I think, is actually a little bit threatened. So the job of the border control is getting even more important. We don't want intruders to access our kingdom. So, okay, let's go a little bit down and move a little bit closer to actually what we're going to solve in a better way. As you can see here, there's a Norwegian passport. I guess many of you have that. And at the right side, you can see a scanner. The Norwegian passport is a quite complicated document, both visually and technically. When I say technical, I mean what's actually inside it. And in order to extract that information, you put that document on the scanner. And then a lot of things is happening. So that is actually our case for today. So this is some kind of overview of our existing solution on what's called scanning of documents. It's just a small part of it, but anyway, it's quite simple thing what we have tried to solve. It's about at the left side we have the scanner, and we have some kind of software which is installed on or connected to the device. And data are actually captured from the chip and transferred to some kind of backend application. At the backend, the content is parsed, it's validated, and we also do some kind of enrichment of the data. And finally, the result is presented in some kind of in our application. It's either a mobile or web application or whatever. Actually, what's happening when we're scanning the document is you get a stream of messages that's vendor specific. Our goal for this data capture there is actually to shuffle the data as fast as possible into the backend where actually the serious stuff is happening, the validation. But before that, we're actually just translating the data into some kind of model, some kind of police model from the vendor-specific model to the police model. So on the left side, it's quite simple, actually. So actually, we thought here this is our perfect Kafka candidate because we're actually already receiving our messages or receiving our data as messages or events. So actually now we're going to look at what is actually inside the document. We have some data holder objects, which is from DG1 to DG15. Right there is only DG1 and DG2, which is the only required elements or messages. DG1 is the same data as you see on the visually part of the document. It's name and date of birth and document number and so on. DG2 is the actual image. And the image should always match the image on the foreside of the document. So that's the data holder object. We also have this cum object, table of content. Quite simple. Just say this document or this chip consists of these elements. And finally, the SOD is this dealing with security. It's certificates, hash values, and so on. So actually what we need is the combination of cum and SOD to validate actually the data holder object, the DG1 and DG2 and so on. This is based on something called the ICAO, which is some kind of international standard. So this is not the, I don't sharing secrets with you right now. It's on Google. You can, yeah. It's used in all kind of traveling documents in the world. So let's move back to actually what we're about something called document validation. This is actually what we want to solve in a better way in our new solution, because all the elements has to be compared either to, for example, the cum, which is the content, or the SOD, in order to do some kind of validation. So actually, of course, there are more elements than this and a lot of validation rules, but the case is actually as simple as this, comparing the elements against the security elements, the cum and the SOD. So just a summary, general challenges of document processing. It's from the vendor side, when you do some scanning of document, the order of the messages is not fixed. It's quite random. So we need some kind of solution which we could deal with that you can get the DG1 and the SOD or the opposite or whatever. There's so many factors involved in when you're scanning a document. There are dependencies across the messages. I showed you in the validation part, because we need to compare things. So you're not able to like validate just one element and then another. You need to wait before you like have some kind of valid combination. There are many different types of documents. Sorry. Like machine-readable documents, which is the most common, those with chip. But you also have other type of documents which doesn't have chip. So then it's actually just a visual part. Despite all well-defined standard, the ICAO, there are too many exceptions. So this has actually affected the existing solution because it was implementing according to some standard. But there are exceptions all the time. Passports from, for example, China, they have done something on their own way. And like the German passport, actually the standard says you should use when you have this country code, should be 3 letters. But they use the D, and then they just fill it out with other symbols. So that, yeah, you need to know that. It's quite frustrating. So actually, this is something we want to solve in our new Kafka solution application. But also, we had some other problems with our existing application, like scalability. A few years ago, we migrated from some IBM application server to Kubernetes. It was on a fixed cluster, but now when it actually was on Kubernetes, it was quite easy to just scale up. And then we realized that the scaling capacity on the application was quite limited. It's not a big problem in practice because we're not Netflix, and we have control of our users. There are not millions of border officers in Norway. There are only 200-300. But anyway, it's this general design principle. All our applications should scale. because we see that the demand for such kind of solution like this is changing. There are more parts of the police that want to do scanning of documents. Lack of performance. The problem in our existing solution that was all the messages has to end at the target node before the processing can start. So that's actually a problem. Like you, for example, have 20, 30 messages, like the DG1 and the SOD status messages and so on. Then, like, you have to wait until you have received all the messages in the document. And that's the problem. We want to start validation and processing from message 1. And so lack of parallel processing was actually the problem. So for this decision, why do we do event-driven architecture? We see already, we have kind of event-driven nature already because we receive the message from the devices. They're already asynchronously. And the police is also already have this Apache Kafka platform. So we found it quite interesting to do that, and all our developers were also so interested in starting working with Kafka because it's but are we actually ready for this change? I think this is adopting new technology. We very early realized that you need to be aware of your own limitations. Actually, I've seen a lot of different applications there here in the police, and actually there's a lot of most of the bad code is written by actually very talented people. Over-engineering is, for example, something which is a big problem. So we were some kind of honest. We need to learn how to walk before we can run. So this has affected how we actually solved our problems. It sounds like common sense, but I don't think it is. Yeah. I'm not going to say so much like the basic in the event-driven architecture because I guess most of you know a lot already. But we have some kind of producers which actually produce the events where they ended up in some kind of ingestion where you have a consumer which actually is able to get the messages or the events from the ingestion. An event is some kind of change in state or an update, like for example this scanning started when we put the passport on the scanner, or DG1 received, DG1 parsed, DG1 validated. They're immutable, so you're not able to change an event. If you want to, you can't update it, then you have to do some operations to undo and compensating actions to, for example, undo it. So our next step now, it's like, okay, we're a team dealing with new stuff. We need some way of how to solve this in a good way. So we're quite inspired by this pattern, rapid rivers and ponds. It's, I think it's a person called Fred George who got the idea for this pattern, but we are quite inspired by the work done by NAV here in Norway, because this is not rocket science, actually. It's quite simple. You have like a message bus. It's one common place, one place where all the events actually appear. So quite limited. You're not dealing with many message buses, just one. And then you can like append as many microservices as you want to, consuming and producing events on that message bus. So one of the pros here is that you have some kind of standardized model, the same semantics for the messages which appear on the single bus here, which then actually called, the name then is Rapid, and the rivers are the microservices. And ponds, in some cases, you maybe need to store your data, either in a database or object storage like S3, for example, and so on. So this is actually, one topic, one domain. It's quite simple. It's quite useful if you have some low volumes, which actually we have. We have not like millions of documents which are scanned every second. I'm going to continue, and later we are actually placing our solution into this kind of pattern. See how that looks. Yeah. A Kafka Apache Kafka. It's you have like brokers, which actually is actually the Kafka server. When your data it's actually stored in topics, which is some kind of category feed name to where the records are stored and published. Partitions is also some very important part, because that's you like divide your data into buckets. So it's it's like a file. So if you have 10 partitions, then all you part it into 10 buckets, and you distribute your data on those buckets. And this is where you, for example, can get a lot of high throughput, because you actually could read in parallel from all the type of partitions. We're also dealing with producers, which are producing events on the topic, and the consumers, which actually are reading the events. So compared to other event-driven implementations, it's you here have a pub/sub. You pull the events from the topic. So you have some kind of offset, which actually is some kind of counter. So you all the time have this counter so you know actually where you are in the topic. So this is actually how our new application, the architecture looks like. We have this Kafka topic, one single topic. We have this parsing, which is a microservice, actually receiving the raw data from the documents and parsing them. That could be like events like the DG1 and DG2 and stuff I talked about, or pictures, for example, and so on. We also have this validation, which actually is the core part of our application, which is actually validating is the document actually valid. So that's the most important part. And finally, we have some kind of enrichment, which we're aggregating data, so it's easier for us to present the data later. And all our is going through some gateway, so we have like a single point where you can access the data. So actually dealing with one topic makes everything much easier, because we have like a simpler model, which actually all our downstream application or microservices could use. So, and you have like this flexibility. If you realize we need some kind of other component here, then you can just append it, and they can actually deal with this, with the same type of messages. So it's quite a plug-and-play architecture. But there are also some drawbacks, and that is all our consumers has to deal with all messages. So that's not a big problem for us because it's quite limited number of messages. But if you have very high volume, I don't think this is a good way of organizing your application. So then we move on. Actually, I talked that we had problems with parallel processing or actually lack of performance. So actually, how do we solve this here in a better way? First of all, we're dealing with, we have 6 partitions. We also have some kind of consumer group. We're able to, so we have then 6 parsers which actually are dealing with the data. So the messages and events are coming in some kind of random order here, but we have some kind of partitioner. So since one scanning has one unique ID, the messages for each document happens on or appears on the same partition. So because of that, we're able to, like, the parser, this parser 1 is allocated to this partition, so they're able to, in parallel, read from all these partitions. And in addition, we consume chunks of data, so that's quite useful. We could, like, consume 20, 30 messages at the same time. And finally, we produce some results, which is, for example, DG1 parsed and DG2 parsed, and so on. And then we move into the other part, which is this validation. So the validators, they keep actually the same pattern here, consuming events in chunks. Actually, you see the validators have some kind of state. It's because the thing I talked about is dependencies. So when a validator receives the messages, it actually stores them to the database. So because you can't start processing them until you have these groups of elements. So that's why we have this database. And also we're dealing with some big data, for example, the pictures and so on. So we don't save, we keep the messages as small as ever possible then. So we just have a reference to the data which are stored in S3. So the validators just look up the data and start validating them. So, and finally, they are also written to the same topic. So this is actually working quite good. Now we're on the next one. We are going to do some demo. We're actually looking at Jaeger. Do anybody use Jaeger today? Know what it is? Somebody? Yeah. So it's actually some kind of tool for visualizing your events. So then I have to do like this. So this is Jaeger. We are now going to look at the events on our rapid. Oh, sorry. Hvordan vil han ikke vise den der? Hæ? Hvorfor gjør han ikke det? Oi da. Ja. Men han er jo. Nei, ser ikke du. Hva ser ikke du? Nei. Så da må du speile skjermen. Det er sånn, ja. Noe dritt. Men det kan ikke gjøres. Så jeg prøver å... Ja. Ja, vet du hvordan den... Ja, det er.
Okay, in the meantime, we can think about some good questions.
Ja, jeg skal bare droppe det da.
Nei, det er ikke det ofte.
Ja?
Så høyre klikker vi på desktopen.
Ja.
Skjerminnstillinger. Så velger vi hvor det lenger ned. Scroller ned der. Og så velger vi der, så velger vi duplisere. Og så beholde det selv. Og da ser du det samme som er. Okay,
Tusen takk. Sorry about that. So actually, you see all these balls there? Yeah. This represents scannings. So if I choose this scanning, I can see all the events which actually happened on our rapid. We have constructed the good part about having this as one single topic is that we have some kind of common model for our events. So all of them inherits common information, and we're also able to connecting messages. So then it's easier using a tool like this to actually visualizing all what is happening. So here we can see some nice representation of all our messages. For example, here we have received this security object. When you receive that, you're actually able to do a lot of type of validation because most elements are dependent on that. So here we can see the time it took to actually do, for example, this validation and the other one. So it's a quite nice tool to have because dealing with events could be quite chaotic and it's very cognitively hard compared to something which is synchronously. So this is a very good way of actually visualizing the content on your rapid, and it's very useful when debugging stuff. So yes, and then we're moving back. So now our third thing was actually about sharing of data, which also has been some quite of a challenging topic for us because our existing solution, it's actually you're not able to share data at all. So actually how it's solved is like you give access to other user groups in the police to the same application. And that's a problem for us dealing, like me working on this team, because we have to take care of different type of user groups. So that was also one of our big things. We wanted to have more sharing of data across different domains. But actually, we are not used Kafka at all here for sharing data because everything is going through our gateway. But that was some kind of design choice we did because even though we want to use Kafka for dealing, we are not quite sure whether we are ready for that. But this architecture gives a high degree of flexibility inside. We can change and do as much as we want. And then we have this gateway where you actually could... it's based on GraphQL, so you have some kind of flexibility in the technology. But but it's not a good way of, actually a good way of sharing. So our goal is actually to take a step further. We're able to publish data on the second topic. So then you get this more like a loosely coupled towards other teams in the police. So this is actually our goal. But this is quite easy to do, to create new topics. It's not a big deal, but there are a lot of questions which appears when you are going to deal data across different domains. So this data as a product, actually what we want to receive is more like enablement over handovers, because we want to share our data with other teams in the police. So we get more autonomous teams. But we also need to host and serve our data sets in an easily consumable way. And probably we need also like interoperability and the standardization of communication. So there's so many questions we need to find the answer on before we actually take the next step. So, like for example, defining an agreement on SLAs and quality measures that we will like have some guarantee to our consumers. And especially the last thing about dealing with authority control, it's quite challenging in the police. It's not like a police officer, you're able to do whatever you want, even though you are a police. The rules are very strict. You can't, someone working on the border crossing are, for example, able to see their data, but they're not able to see data from some other parts of police. So it's very strict. So this is challenging. So that's why we waited. We want to have data as a product. That's our final goal. It's so cool. And so finally, if we now ask the question again, well, how can Kafka help us catching criminals? Actually, what I say, what is the value of sharing data in real time? For example, if you have events like, this is just some story I made up in my developer head. It's nothing. It's just a car is stolen, a patrol one arrives at crime scene. Then you have some burglary. Another patrol is arriving at the crime scene. And finally, a person is arrested at the airport. What if we're able to share these notifications or data with, for example, the patrols? I think the police, it's actually getting the correct data as close to actually, for example, the crime and things which are happening. It's so important. You can't like waiting 10 minutes and or now 10 days, and you need them as close to when things actually are happening. So far we thought that this has been a very useful project. As I said, we had to learn to walk before we could run, and we're really looking forward to running. Actually, is there any questions? Yeah, sure.
You are sharing. Yeah, hi. So you are sharing data in real time over internet.
Over internet?
Yeah. So you have a device which will scan.
No, no, and we're not using the internet in the police. No.
Okay. Yeah, because I was like,
it's a good question, but we're not able to do that because it's like the cloud and all that. It's a challenging thing for the police. Yeah.
Yeah. Thank you. Yeah.
Hi, you touched a little bit on authority control, but from a team perspective, I can understand it's quite easy to separate. But from an engineer, when you have control of the message bus and you have all the handlers and everything, how do you go about solving not having access to everything at once?
Not having access
to every data about every document and everything at once, because if you put machine learning or you put something in between into these messages, you can quite intrude on the personal identity of a lot of people that are not in the criminal investigation. And that is quite a problem when you're doing event-driven architecture.
This is very tough material, both a little bit technically and also the laws. So we're trying now to addressing these challenges in our company, and we really hope that they start a job like how to solve them. I'm not quite sure. It's not. Yeah, I'm sorry I can't say nothing more than that. But we're right now we're like have flagged it. We need something here. It's easy to share them, but we don't. How should we control that? The data from actually, is it your data or your data and whatever? That's not so. It could be quite challenging.
And have you planned anything for the traffic during Christmas? There will be a lot of scanning,
Yeah,
a lot of data.
Yeah.
So regarding scalability, and also, are you taking any backups?
Backups of our data. What do you think?
Kafka data.
Wha-
Data in the topic.
Yeah, we have some. We use some replication. We have actually three brokers, and with the replication our data. So we have a copy of all our partition distributed on our brokers. So we're actually able to, like if you have failover or something like that, to handle that. But when the data set, when you do a scanning, actually the data is only. It's when you do the scanning, they're interesting, because the consuming parts, they're actually saving them if they're interested in the border officers. But after, then the data is not so interesting anymore. So we're not going to use the topic as some kind of storage for all the data. We're actually deleting them. So because of that, we maybe not need replication at all, because the result, if we have some problem, actually they have to do the scanning again. Yeah.
Hi. I read articles talking about the Kafka is not as efficient as Google pops up. Have you experienced that? Was it delay, or do you take some measures to improve Kafka speed, or it meets your service level agreement needs?
Yeah, it's in our world, which is quite. We like use Kafka in some quite limited case, like this processing of messages, and so our volumes are quite low. So for us, it's working very good, and we have not looked at other things because other technologies and platforms, because we have to deal with what is the standard in the police, and it's Kafka right now. Of course, we're running on Kubernetes, so we're able to actually host them by ourselves, but that's not an alternative for our team. So, yeah, that's all I could say about that.
Hello. Can you hear me? Yes. I have a question. It's sort of related because you mentioned a couple of goals you had when for actually using Kafka. One of them was performance, but the other was simplicity. Do you feel that you reached your goals in say the simplicity part, and also of course the performance? Is it quick enough through the whole chain? And how do you actually set your goals or specific?
As I said, our limitation was like this lack of performance and scalability, and also sharing of data, that was our main goals. But also, we realized that implementing this rapid reverse upon makes this simplicity, which is. It's actually very easy to just append other microservices. We really realized, okay, we like started with this parsing. You need to parse the raw data. to JSON and some formats you could deal with, and then you have to do the validation. And then we realized, how should we actually construct the results? Because we need to say to the our solution that the result of the scanning was that it was, for example, manipulated, or it was illegal, or whatever. So then we added a new microservice to our solution, which actually did that job. So that was the simplicity of this pattern, but it only works, I think, with low volumes. It's not. I don't think it would work if you have like huge amount of data.
Yeah. How do you do operations? Is it driven by the team? Are you monitoring Kafka, or is it an ops team that does that for you?
We have an ops team that is dealing with Kafka. So as a developer, I'm actually using Kafka as some kind of service, you could say. So we're like we configure our consumers, like how many brokers, how many replicas you want, and things like that. And then we apply that to our platform. So we have own people who are dealing with Kafka, like we have own people dealing with Kubernetes and other platforms.
And have you had any operational problems running it that you have noticed, or it has been smooth sailing?
So far, so good. But of course, later when we start to use this in bigger scale, I guess we would probably see a lot. But right now, we're mainly using Jaeger and tracking and seeing what is happening. And yeah, so there's not been any problems. But as I said, our world is quite simple. It's a strategic choice, like starting to deal with something simple, and then move on with bigger changes.
You mentioned that not everyone follows the standards accordingly, or how they're supposed to be followed.
Yeah.
How do you do error handling here? Like if somebody had changed something without telling you guys, how do you deal with errors?
Actually, if you like receive some kind of, if you're doing some kind of validation then, and let us say it fails, so then that event is actually, we have some kind of transaction around our producers and consumers. So if something fails, then the events are actually led back on the topic, and then you read it again. So yeah, we have like this read one or process one strategy. So read once, yeah.
Okay, any more questions? Yep. I think you need it for the...
So do you have any bigger plans for this? Because I think like for like the common people, like, you know, normal people like us, like if your car gets stolen or your boat gets stolen, do you have any bigger plans for this? Like you're talking about sharing data. Do you have like, if it's event driven, like if something happens in, let's say Stavanger, like a boat or things get stolen, but it gets shared with the border police and then perhaps shared with Denmark and Sweden, stuff like that, so you can stop it before it actually gets out of the either our country or Sweden and Denmark?
Very good question. I think Rune,
it's a very good
some help.
question. As a on our team, we're just burning to take the next step. But it would always be like that in an organization like the police. We need to wait and see actually how should we deal this data. But the day when we have that, we're actually we're able to like you can like get a picture of everything happening in real time. There are so many opportunities there. It's just your imagination. Yeah. Actually, the perfect thing, the day where you actually can start predicting data, naive crime. Actually, you know before it happens that this case is some kind of strange. Take a look at it. So, but I really hope that we very soon are able to share more data across our application, because there are a lot of data in the police. There are tons of applications, and we need to do more sharing. Yeah.
Skal jeg bare svare litt på den, Rune? I got the mic right now to answer that question. I can introduce myself, Hafsa Ilkam, and I work at the police unit here for IT unit. And we are plans on your question. We are actually now working on establishing the police's first product area, where we looked at the whole value chain from an incident to when the case is settled. So we will say we're going to use Kafka here too, and we will look at the whole process from egentlig A to Z. But we are on a planning level right now. So we have not started yet, but we are establishing the first teams, 4 product teams, and we are right now hiring more. So if you want to know more, so just come to me later on the break.
I think like
okay,
like the performance things and scalabilities, that's good things, but it's the sharing part which is actually very interesting for the police. Because, yeah, question?
Yeah, I have more of a meta question. Why documents when these days we can have biometric scanning and all those like more accurate data points?
Yeah.
Why are we still relying on paper documents?
Yeah, actually where our application, or in Norway, we sooner or later now have to deal with biometrics, but it's not like everybody's not like Norway. There are many countries in the world.
Yeah.
And actually, there are many countries today which just dealing with passwords which are not machine readable at all. It's just a document. So then it's 100% manual process of the officer to check whether it's valid or not.
Okay, I think it's like one more question and we need a break.
So you mentioned you're doing enrichment of the data that comes into Kafka.
Yeah.
Are you using Kafka streams?
No, but we have read a lot about it, and I hope that's on our second iteration of because that's probably maybe one more elegant way of doing it.
Exactly.
As I said, we're like adopting new technology. We have to be careful, and that's probably it sounds so common sense, but there's so many times like we are developers, we want to just make the perfect, we want to make the Porsche or a Rolls Royce at once, and you end up with nothing. So, yeah, Kafka streams, it's on our list.
Awesome.